Have you ever considered how competition can spur progress, even in a field as abstract as mathematics? Imagine the world of mathematics as an arena, where geniuses engage in intellectual duels, their weapons of choice being theorems, proofs, and equations. These clashes, far from being petty squabbles, have historically been the driving force behind some of the most significant advancements in the field. Let's delve into the realm where numbers and logic reign supreme, and intellectual confrontations are not only inevitable, but integral to progress. A realm where the quest for truth and understanding often leads to fierce competition, challenging the status quo, and sometimes even rewriting the rules of the game. It's a realm where the giants of mathematics have often locked horns, leading to earth-shattering revelations and paradigm shifts. One such iconic duel unfolded in the 17th century, a bitter dispute that would forever change the trajectory of science. This was the Newton-Leibniz calculus controversy. On one side of the ring stood Sir Isaac Newton, the revered polymath and the apple of England's intellectual eye. On the other side, we had Gottfried Wilhelm Leibniz, the brilliant German philosopher and mathematician. The bone of contention was the invention of calculus, a revolutionary mathematical framework that laid the foundation for countless scientific discoveries. Accusations of plagiarism flew thick and fast, casting long shadows over the reputations of these two luminaries. Yet, amidst the acrimony and intense rivalry, the unfettered spirit of inquiry persevered, pushing the boundaries of human knowledge and understanding. So here we are, at the cusp of an intellectual journey that traverses centuries, a journey that will take us through some of the most heated debates, unexpected triumphs, and enduring legacies in the world of mathematics. These are the tales of brilliant minds in conflict and collaboration, their relentless pursuit of truth, and the profound impact of their intellectual duels on the mathematical landscape. And thus, the stage is set for the duel of brilliant mathematicians. In the 17th century, a bitter dispute erupted between two mathematical giants, Isaac Newton and Gottfried Wilhelm Leibniz. This feud, known as the calculus controversy, was ignited by a contentious question: who invented calculus? Newton, the English polymath, claimed that he had developed the principles of calculus during the mid-1660s. However, he did not publish his findings immediately. Meanwhile, across the Channel, Leibniz, the German philosopher and mathematician, independently developed and published his version of calculus in the late 1680s. When Newton's work finally saw the light of day, a storm of accusations swirled. Newton's supporters accused Leibniz of plagiarism, while Leibniz's advocates claimed that Newton had surreptitiously stolen their hero's rightful credit. The ensuing battle was not just a clash of mathematical minds, but a war of words, accusations, and national pride. Yet in the midst of this turmoil, a silver lining emerged. The duel between Newton and Leibniz spurred further advancements in calculus. Their respective notations and methodologies, though distinct, contributed to a more versatile and comprehensive mathematical framework. Newton's fluxions and Leibniz's infinitesimal calculus, though fraught with disagreement, ultimately enriched the field. This controversy had far-reaching implications beyond the realm of mathematics. Calculus, a tool for understanding change and motion, revolutionized the world of science. It became instrumental in the development of physics, enabling scientists to describe the motion of planets and the forces of nature with unprecedented precision. It also laid the groundwork for future scientific revolutions, from the theories of electromagnetism to the principles of quantum mechanics. Despite the controversy, this duel catalyzed the development of calculus, setting the stage for future scientific revolutions. It's a testament to the fact that sometimes, in the realm of intellectual pursuits, conflict can be a catalyst for progress. As Newton and Leibniz's tale reminds us, the journey to truth is seldom straightforward, but it's the twists and turns that often lead to the most profound discoveries. Fast forward to the 20th century, a graduate student named George Dantzig unwittingly solved two unsolvable problems. This was not a typical duel, one might say, but rather a clash of intellect between Dantzig and the formidable mathematical challenges posed by David Hilbert. Hilbert, a luminary in the mathematical world, had created a list of 23 problems, the solutions to which he believed would shape the course of mathematics for the century to come. Two of these problems were considered so formidable, so complex, that they were thought to be unsolvable. But Dantzig, unaware of the problem's reputations, took them on as a challenge. Dantzig's approach to these problems was not one of a seasoned mathematician, but rather of a student, eager to learn and undeterred by the supposed impossibility of the task at hand. He toiled on these problems, applying his knowledge and intuition, not knowing that he was attempting to do what no one else had managed to do before. After several weeks of relentless work, Dantzig succeeded. He had found the solutions to Hilbert's unsolvable problems. When Dantzig presented his solutions, his professors were astounded. They couldn't believe that a student had achieved what the greatest minds in the field had deemed impossible. Dantzig's triumph was unexpected, to say the least. His achievement was not just about solving two problems. It was about shattering the notion of impossibility. It was about demonstrating that with perseverance, with tenacity, and with an unyielding belief in oneself, even the most formidable challenges can be overcome. This unexpected victory served as a testament to the power of perseverance. It showed that breakthroughs could come from the most unlikely of places, from a graduate student who dared to take on the impossible. Dantzig's triumph was not just his own, but a victory for all of mathematics. It served as a reminder that the boundaries of human understanding are not fixed, but can be pushed, expanded, and reshaped by those who dare to challenge them. In the face of seemingly insurmountable challenges, Dantzig's unexpected triumph showcased the power of perseverance and the potential for breakthroughs. His story continues to inspire mathematicians, urging them to challenge the status quo and to always strive for the impossible. Mid-20th century witnessed a profound debate about the nature of mathematics and computation between Kurt Gödel and Alan Turing. This intellectual duel was not just about who was right or wrong. It was a quest to further our understanding of the mathematical universe. Gödel, an Austrian logician and mathematician, was already renowned for his incompleteness theorems. These theorems fundamentally challenged our perception of mathematics, questioning the completeness and consistency of formal mathematical systems. Gödel's work was a revelation. It suggested that within any given system, there would always be statements that cannot be proven within the confines of that system. This was a groundbreaking idea that shook the mathematical world to its core. It was a stark reminder of the limits of formal logic and the inherent uncertainty that lies at the heart of mathematics. On the other side of the duel was Alan Turing, a British mathematician, logician, and computer scientist. Turing is often hailed as the father of modern computer science. His work on computability and the infamous Turing machine laid the foundation for the digital age we live in today. Turing proposed a hypothetical machine that could simulate the logic of any computer algorithm, no matter how complicated. While Turing's work was more practical compared to Gödel's theoretical approach, both their contributions were pivotal in shaping our understanding of mathematical logic and computation. Turing's work gave us a practical tool to navigate the digital world, while Gödel's theorems challenged us to question the very foundation upon which this world is built. In this intellectual duel, both Gödel and Turing transformed the way we perceive mathematics. They didn't just provide answers, they made us question our assumptions, pushing us to explore new paths in the vast landscape of mathematics. Their duel illuminated the profound and sometimes paradoxical nature of mathematical logic, laying the groundwork for modern computer science. This duel, like many others in the history of mathematics, serves as a reminder that every question, every challenge, and every debate brings us one step closer to unraveling the mysteries of the mathematical universe. Beyond individual rivalries, the dynamic tension within mathematics propels the discipline forward. This statement holds the essence of the ongoing duel within the mathematical community, a duel that is both relentless and captivating. Take, for example, the pursuit of the twin prime conjecture. For centuries, this problem has held mathematicians spellbound, asking whether there are infinitely many pairs of twin primes. The question remains open, unanswered, like a riddle waiting for its solver. This duel, however, isn't just about finding answers. It's about the journey, the process, the collaboration, and the strategies employed by mathematicians. It's about the intellectual tussle, the sharing of diverse perspectives, and the relentless pursuit of truth. Each attempt, each hypothesis, each solution proposed adds a piece to the vast jigsaw puzzle that is the mathematical landscape. But what is the legacy of these intellectual duels? Well, they shape the very culture of mathematical inquiry. They foster an environment where creativity and rigor coexist, where competition and collaboration are two sides of the same coin. These duels spark curiosity, fuel passion, and drive innovation. They push boundaries, challenge norms, and inspire a quest for knowledge that transcends personal triumphs. The duel of brilliant mathematicians is a testament to the vibrancy and dynamism inherent in mathematics. It's not a battle of egos, but a crucible for refining ideas, for testing theories, for advancing our collective understanding. It's about the celebration of the human mind's capacity to explore, to question, to solve. More than just a clash of intellects, these duels are a beacon of inspiration. They highlight the power of perseverance, the importance of critical thinking, and the joy of discovery. They serve as a reminder that every challenge encountered, every problem unsolved, is an invitation to learn, to grow, and to contribute to the ever-evolving body of mathematical knowledge. As mathematicians engage in this perpetual duel, they not only enrich the field with groundbreaking discoveries, but also inspire future generations to embrace the challenges and triumphs that define the ever-evolving landscape of mathematics.